Not enough time to revise Add Maths before your exam? Don't worry, I've got you covered. Hi, my name is Terry. With over 25 years of teaching experience, I've created Express Notes to help you focus on the most important concept and question for your exam. Today's topic is chapter 1.3, inverse function. So let us get started.
Inverse function is like the opposite operation. For example, fx can be 2x. 2x means it times 2. The inverse will be x over 2. So one thing you need to know is that a function, right, when you inverse it, the original relation may be 1 to 1. When you inverse it, becomes also 1 to 1. But for many to 1, you inverse it, becomes 1 to many. Now, how come I didn't put 1 to many here? Because 1 to many by itself is not a function. If it's not a function, it doesn't have an inverse. All right? Okay, so 1 to 1 has an inverse. Many to 1 has no inverse. Why? The moment you inverse, it becomes 1 to many. When you go in the opposite direction, for example, this is many to 1. Two objects map onto the same image. If I go from left to right. If I go from right to left, it becomes 1 to many. So I cannot say this is a function. All right. So yeah, we have what we call a vertical line test. I don't know whether I wrote here now. A vertical line test. Just now we did a vertical line test. This one we can use what we call a horizontal line test. A horizontal line test means I give you one example. We have a curve like this. I don't know whether this has inverse. We draw a horizontal line. If you cut at 2 points, it has no inverse. If you cut at 1 point, it has inverse. Why? When you cut at 2 points, you know this will be many to 1. Many to 1 has no inverse, right? If you cut at 1 point, it has inverse because it's 1 to 1. For example, I may have a curve like this. Does this function has an inverse? Yes, I cut across. I cut only one time. It has 1x mapped onto 1y is 1 to 1. Therefore, this one has an inverse. Yes, this one has no inverse. Okay, let's look at one example. Example number 17. Okay, what type of relation is this? This is many to 1, right? So normally, they ask you whether it has an inverse or not. Determine with a reason. Give a reason. The reason is many to 1 relation. We know many to 1 has no inverse. Second one, we can use what we call a horizontal line test. We cut across. You notice you got one x value that map onto one y value. So we say is 1 to 1 relation. And 1 to 1 relation, for sure, you have an inverse. Okay, just write yes. The function has an inverse. There are two ways to calculate that. Some of you may want to use the old textbook, the new textbook. But I like this old textbook. I'm using this method actually, the first method here. I always let whatever I wanted, let it be y. The new textbook or the current textbook that you're using is whatever that you're given equals to y. They are completely opposite. So why? So when you, like for example, let's say for example the first one, I let my f inverse x becomes y. That means I go backwards. Originally, I start with x, I end at y. If I go opposite, we say fy is now x. My object is y, my image is x. So in this case, you're finding who as a subject. If you let f inverse x becomes y, you're finding y as a subject. If you are letting fx becomes y, you're finding x as a subject. The other way around. Okay, so you decide whichever method that you wanna. I like to use this method. Yeah, I like to use this one. Okay, but if you are used to using the second method here, go ahead. Okay, and to inverse a function, some of this you can actually do mentally. Don't have to do one by using a normal way. Like for example, opposite of plus, when the inverse becomes minus, minus becomes plus, times becomes divide, divide becomes times, and so on. Okay, all right. So let's look at example 18. So I show you the standard way. I like to use this method because, right, in the event that you are finding f inverse of a number, you don't have to find the inverse function. A lot of people, right, if you're using the textbook current textbook method, you need to let fx equals to y. You need to inverse a function first. That means you actually have to do b before you can do a. So what I'm suggesting is some question you're not supposed to find f inverse x. You're supposed to find f inverse 2 directly. So I like to let whatever I'm finding, whatever I want to find, I want to find f inverse 2, I let it be y. Then I switch the position. We say fy is now 2, right? I switch the y and x as the object and the image. I know fx is 3 over x minus 4. Fy is 3 over y minus 4. I'm finding y. Bring over. So 3 over y equals to 6. Bring this up, bring this down. Y is 3 over 6. 3 over 6 is 1 over 2. And this is your f inverse 2. The result is also 1 over 2. Okay, next. What is your f inverse x? Same thing. I'm letting this be y. I say fy is now x. 3 over y minus 4 is now x. Bring it over. 3 over y is now x plus 4. Bring the y up. Bring the x plus 4 down. Y is now 3 over x plus 4. And what's your y? Your y is your f inverse x. There you go. That's your answer. We write x cannot be negative 4. The way I'm doing it is I like to let whatever I'm finding becomes y. I write gx equals to y. So you switch the position. G inverse y is now x. So we sub inside because I know g inverse x. So this is 2y minus 1, y plus 5. I let it be x. I'm finding y, right? So 2y minus 1 is xy plus 5x. Since I'm finding y, I group all the y on the same side. I bring over. 2y minus xy is now 5x plus 1. Make y as a subject. Take out your y. You're left with 2 minus x. The result is 5x plus 1. Okay, your y is therefore 5x plus 1 divide 2 minus x. Okay, what is your y? Your y is your g inverse x. And this is 2x minus 1. Sorry. Your y is not your g inverse. Your y is your gx. And it's now 5x plus 1 over 2 minus x. We write x cannot be 2. Okay, for part B, defining the value of x such that gx equals to negative 3. Now, a lot of people would tend to use this result and let it be negative 3. Now, I don't want to do that because if you do that, then you have to rearrange to find the x. For me, I would switch the position. You know that you can interchange your object and image, your x and your y. Your g inverse negative 3 means I put negative 3 inside here. You will get 2 times negative 3 minus 1 divide negative 3 plus 5. The result is x. So this is negative 7. Negative 6 minus 1, negative 7. Negative 7 divide by 2. X is minus 7 over 2. All right, guys, this one involving composite function. You're finding the value of g inverse h5. Okay, maybe I find h5 first. What is h5? h5 means you're putting 5 inside. Okay, I have a few ways of doing that, but I think most people would probably go and inverse the function. But actually, the g inverse is also not difficult to find, guys. I'll just do like this. Because your g inverse is what? Remember, this one means you first times 2, then you plus 3. The inverse will be first you minus 3, then you divide by 2. You can do this in one step. You don't have to show any other working. So for a linear function, the inverse is only 1 mark. Okay, so this is your g inverse. Okay, maybe I do g inverse h5 straight away. I put 5 inside my h. This will be square root of 5 minus 4, which gives us 1. G inverse 1. So take 1, sub inside here and here. You should get 1 minus 3 over 2. Answer negative 2 over 2, which gives us negative 1. Okay, how about this? Hg inverse x. For me, I would first let this be 1. And remember, we interchange your object and your image. The moment you interchange your object and image, the negative 1, the inverse sign disappears. So this is hgy equals to x. take this, sub inside. You know your g, right? Your g is 2x plus 3, but this is gy, so you write 2y plus 3, and take this, sub inside your h, square root of 2y plus 3 minus 4, the result is x. So what I need to do is to subtract 2y minus 1 square root equals to x as I square left hand side and the right hand side. I will get x squared plus 1 here. As you divide by 2, x squared plus 1 over 2. I'm writing a lot of steps, but actually you can cut short. Your y itself is your hg inverse x, and this is x squared plus 1 divided by 2. So here, in the event that you're given a function, but yes, unknown inside, there's another inverse, there's another unknown. So you inverse the first function compared with the second function. So we let whatever that you're finding becomes y. Your fy is now x. A over 2y plus 5 is now x. So switch this upside down. Make y a subject. A over x is, okay, I tell you what, I just change it. So a over x equals to 2y plus 5. 2y is a over x minus 5 divided by 2. When you divide by 2, you get a over 2x minus 5 over 2. Now, this is basically your inverse. So I don't do too many steps. So I'll just copy this on the left and compare this on the right. Again, now we are using comparison, right? Yeah. This is a coefficient of 1 over x, right? So you're comparing with your coefficient of 1 over x. You can see a over 2 is now 3, a is 6. You can also compare your constant. What is your constant? Your constant is negative 5 over 2 is now b. Can I just write b equals negative 5 over 2? Look at this. This is your b. Right? Simple. Inverse the first one, compare with the second one, and solve for a and b. So normally you're given a function like f and g. They ask you to find g of x and g x. But this one, they give us fx. They give us gx. They tell us what is a combination that gives us this, the combination of g or f. Okay, in a way, some of you may say it's like a trial and error. True, but it's 1 mark each. This will be a so-called shorter, simpler question. Now, your x minus 3, you can see is fx. That means fx happens first, right? So when we do this, this is your working, it's not your answer. You're not sure whether it's gfx or fgx. It's for me to validate. My fx is x minus 3. You sub inside your g. So this is the square root of x minus 3. And therefore, this, we know, confirm that your answer, the combination that gives us this is gfx. Okay? Okay, second one. Well, I have minus 6. And you can see minus 6 is basically minus 2 occurring twice, isn't it? Minus 3, minus 3. This is minus 6. So I'll just validate by doing f2x. f2x is ffx, meaning we put fx inside fx. So it's x minus 3 minus 3. My answer is x minus 6. So I confirm this is true. We say that your answer is f2x. Okay, the next one. You can see this is x squared plus 3. Okay, one thing to take note. There is no x squared here. No? But remember, inverse is the opposite operation. This gx itself is square root x. If you inverse the g, opposite of square root is square. And notice this is a minus, whereas this is a plus. Opposite of minus is a plus, right? So we know we have to combine g inverse and f inverse. So you can combine these two and say, okay, maybe I put, the one that happens first is g inverse, right? So we say f inverse g inverse. That is, I put my g inverse first, which is x squared. Then I sub inside my f inverse. which is x squared plus 3. So your answer is F inverse G inverse. Now, however, some of you may say, I noticed that this, in fact, is this inverse. You realize that or not? If you take this, you inverse it, you square first, then you plus 3, you're actually getting exactly the same thing. So another way of doing is you already know your GF here, right? We just take this and inverse it. You let it be y. You know your GFY is now x. Square root, sorry, no space. Y minus 3 is x. Make y a subject. Your y is x squared plus 3. What's your y? Your y is GF inverse x, x squared plus 3. So that means that there are two possibilities for answer. It can be F inverse G inverse, or it can be GF bracket inverse x. They are the same, guys. They are the same. Okay. Your x value is your domain, y value is your range. Now, when you inverse, what happens is that your x becomes y, your y becomes x. For example, this original point maybe is, let's say, 5, 4. So when you inverse it, it actually it is like a reflection in the line y equals x. You reflect over, right? Your mod maths transformation, right? Reflect over. So this point end up here. This point, okay, I use a different color. This point end up here. So if you join together all the points, you actually get this graph here, your F inverse. Yeah, and not only that, number one, it's a reflection in the line y equals x. Number two, all your domain and range will interchange. Your original domain, like for example, your function fx has a domain of, let's say, x greater equals a. Then let's say your function, your range for fx, let's say is y greater equals to b. The moment you inverse, the domain for your fx becomes the range for your f inverse. Your range for your fx becomes the domain for your f inverse. They basically switch position. All right, let's look at one example. This graph is already drawn for you. Example 23. You're supposed to sketch the graph of f inverse. Okay, not difficult. So number one, I will draw my line of symmetry here, then my line of reflection. This y equals x is the line y equals x. Okay. Number two, let us plot maybe a quick one. This point here, this one is now, instead of 1, 0, it becomes 0, 1. Then I need to draw a curve upwards, right? Instead of 5, 3, it becomes 3, 5. So the red graph here is your y equals f inverse x. The blue graph here, original graph, is your y equals to fx. And your line of reflection, y equals x must draw, is the orange graph. Now, you're also supposed to state what is the domain and range for your f inverse. Remember, your f inverse is your red one. Domain is your possible x value. Okay, my x value starts from 1 to 3. So we say domain is 1 to 3. Range is your y value. Your y value goes from 0 to 5. So we say f inverse x is between 0 to 5. The last example is we have to inverse the function first, right? Then we sketch a graph. Okay, so the first part, I think even this inverse function we can do mentally. Yeah, because this is typically, this is 1 mark. So your fx is 3x minus 5. When you inverse it, you see, originally you first times 3, then you minus 5. When you inverse it, the operation is opposite. The sequence also opposite. First you plus 5, then you divide by 3. Okay, that's part A. So I don't do extra. You want to do the standard way, you can. Okay, second one, sketch a graph. Okay, for fx, or should I write 3x minus 5? We just have to sub in two values. X equals 0, y equals 0. When your x is 0, your y is negative 5. When your y is 0, your x is 5 over 3. So 0, negative 5, maybe here, negative 5. One thing, please draw such that the ratio is 3:1. Because I do have students from the other class, they draw them parallel. You need to show the intersection. Why do I say that? Because this 5/3 is actually 3 times smaller than the magnitude of -5. Because some people, they draw like this. They say, hey, how come my graph like that doesn't intersect? Because your scale, to a certain degree, don't have to be 100%, but make sure it looks like 3 times smaller so that the line will look like they intersect. This is your y equals fx. Okay. Now, the second one I'm going to draw is the line of reflection, your axis of reflection, y equals x. Normally, we use the dotted line. Just use the dotted line. Draw here, y equals x. And the third line I'm going to draw is your F inverse. Now, notice they will intersect. Okay, something like that. They will meet at line y equals x. They're supposed to meet. If your line does not meet, something is wrong. Okay, so this your y equals F inverse x. It should intersect at this point. This is -5. This is 5/3. And my graph is done. Okay, I still have to do one last thing. State the domain and range. Very simple. Your domain here becomes a range. Originally, your range for fx is -5, right? -5 onwards. So let's just focus on the red line. Your domain, your F inverse, is x greater equals -5, whereas your range is your y value. The whole graph is above the x-axis. So we say your y of your F inverse x is greater equals 0.
If this video helped you, you can get my Add Maths book from Shopee or Lazada, or by searching Teliti. For full step-by-step learning, check out my e-course or join my classes at Pusat Tuition Teliti. Remember to like, subscribe, and share. See you in the next video.